Okay, so this is going to be part 2, where we're talking about the golden penny. Now, we're going to talk about this in a couple of different sections. And so what we're going to do for our experiment is we're going to take a beaker and we're going to fill it with 1 molarity of KOH. Oh, not KOH, NaOH, sodium hydroxide. Now, in this sodium hydroxide, we're going to put in some copper. And so we're going to put in copper down at the bottom. So these are the penny coins. We're going to put a total of 4 of them in there. And so this is going to be the bottom of the beaker. So if you imagine that you're from the top looking into the beaker. And so when we add those pennies in, our 4 is going to sit 2 on one side and 2 on the other side. Now what's different about this is that one side will have what we call a zinc mesh. So basically it's like a screen of zinc. And the other side won't. So when we put those 4 pennies down at the bottom, we have 2 on one side and 2 on the other. Now, we're also going to put in a couple other pieces. We're going to put in a penny that's connected to a wire. And we're going to put in a penny that's connected to a piece of zinc. And both of those are going to be submerged inside our NaOH solution. And so we're going to look at them and we're going to talk a little bit about what happens to each one. So when we first put in the pennies, they all stay orange. But over time, things start to change. Some of the pennies start to transition from being orange, right, which is our copper color, to being a silver. Now, if I drew them in silver, it would be hard to see on the white background. So any of these pennies that look like they're red, this is going to be a penny that's turned silver. So the first ones that we start to see is these ones down here. Both of those pennies that were on the zinc mesh turn over to be silver. The other penny that turns silver is this one here. It's a penny that's suspended inside of our solution, but it's connected by this wire to our zinc. So those 3 pennies turn silver. The other 3 pennies stay looking the same as what they were before. So no change for them. Now, as this goes through, we do see some very tiny bubbles form on the zinc surface, but those bubbles aren't very fast, right? A little bit slow. And so when we look at this, we want to kind of compare that. And so what I've done here is I've taken 2 beakers, or not beakers, 2 test tubes, and in one of them, I added in that same zinc mesh that we had before. And in the other, I added in the zinc as a powder. And what we notice is that there are bubbles that form for both of them. But there's a lot more that bubbles that form in the zinc powder, or at least a much faster rate of bubble formation. Compared to that of our zinc mesh. And so while we do see bubbles that are forming, and so bubbles kind of give us an idea that there's a chemical reaction that might be going on there. And so we might want to think about what bubble, or sorry, not that, what gas might be forming, right? And then if there's a gas forming, what does that mean about our zinc part? What we do see is that there's a much faster evolution if we have it as a zinc powder compared to a zinc mesh, right? So us having that surface area to interact with the solution does change things for us. Now, as that continued on, we see those changes. And so to kind of give us some electrochemical background for it, we went ahead and we put in some leads in there. And we measured the difference between the voltage of the penny versus the voltage of our zinc. So we're connecting our copper to our zinc. And so what that kind of looks like is that we're taking and we're connecting to this copper wire here. So this is going to be our voltmeter or multimeter. And then the other one is going to come over here and we're going to connect it to a piece of zinc. Oh. Now, when we first put those in and we start to measure, we notice that there is a voltage of about 0.15 to 0.3 volts difference between them. And the zinc seems to be our negative terminal compared to the positive of the copper. Now, as we allow those to sit over time, we start to notice that that voltage difference decreases. It starts to go down from that 0.15 to 0.3. It starts to go down, 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 and it ends at like 0.03 volts, right? So pretty close to zero. Again. And so with that information together, we should be able to figure out what's been happening inside of our penny. What do we need for things to occur as it's working its way through? And the second part is that as we're looking at them, and then the second part is that as we start to walk through this and we do our consider this, there's some things that we want to consider, right? When you're thinking about how your system is kind of coming together, was it enough for our zinc to just be in presence with copper? Do they need to be in contact? Do they need to be close to each other? Right? You want to be working your way through that. You want to think about what is being transferred where, right? So that wire that's connecting them, is it transferring atoms? Is it transferring electrons? Is it transferring neutrons? What is it? Protons? What is it doing to connect those two things together? And so we should be able to figure out all of our consider this, as well as our part 2 for our explanation through here. All right, good luck.